Welcome to the Introduction to VXLAN module. By the end of this module, you should be able to describe VXLAN fundamentals. Virtual Extensible LAN or VXLAN is defined in RFC 7348. VXLAN, a framework for overlaying virtualized Layer 2 networks over Layer 3 networks, and describes a method of tunneling Ethernet frames over an IP network. RFC 7348 describes the data plane and a signaling plane for VXLAN. Although RFC 7348 supports protocol-independent multicast or PIM and multicast in the signaling plane, other signaling methods for VXLAN exist, including multi-protocol BGP or MPBGP, Ethernet VPN or EVPN, as well as Open vSwitch Database or OVSDB. Refer to the Juniper Pathfinder website for the current list of devices that support VXLAN. You can access the website from the reference links document. The diagram shows the encapsulation format of a VXLAN packet. It is important to remember that adding a VXLAN header requires managing the Interface Maximum Transmission Unit, or MTU, of the fabric interfaces to avoid packet fragmentation and drop. This configuration shows the interface settings used in our examples. The diagram shows how a virtual tunnel endpoint or VTEP handles a VXLAN packet on a source VTEP that must be encapsulated and sent to a remote VTEP. Here is the step-by-step process taken by the network. 1. VM2 sends an Ethernet frame to the MAC address of the remote bare metal server or BMS. 2. The Ethernet frame arrives on the interface connected to R1 VTEP. 3. R1 VTEP receives the incoming Ethernet frame and associates the VLAN on which the frame arrived with a virtual network identifier or VNI. One thing you should notice about the VLAN tagging between the VMs and the virtual switches is that, since the VLAN tags are stripped before sending over the IP fabric, the VLAN tags do not have to match between remote VMs. This provides more flexibility in VLAN assignments from server to server and rack to rack. 4. R1 VTEP analyzes the local VXLAN bridging table to determine which remote VTEP has advertised the MAC address associated with the destination MAC address in the received frame. 5. R1 identifies which VTEP interface tunnel next hop should be used to forward the frame. 6. R1 encapsulates the original Ethernet frame in a VXLAN IP packet with a destination IP address of the remote VTEP address and forwards the IP packet to the next physical device in the IP fabric. 7. The remote VTEP R2 receives an IP packet destined to the IP address associated with the local VTEP tunnel endpoint. 8. The IP packet is decapsulated, which exposes the VXLAN header that contains the VNI value associated with the Ethernet segment. 9. The remote VTEP removes the VXLAN encapsulation and forwards the original Ethernet frame out of the interface associated with the destination MAC address in the local bridging table. If the local interface has a VLAN tag associated with it, the VLAN tag associated with the VNI is included in the transmitted frame.